Now, this is a tough question when you do it for the first time, but I will teach you a technique that will make it very easy. And is a similar question to a MCQ before this. And you notice that you have two unknowns. You need to find the outward force on P and the outward force on Q. And whenever you detect two unknowns in such a question, you will have to use two equations to solve the two unknowns, as I mentioned in the previous MCQ explanation. So I will use POM to create one equation, and I will use Newton's second law to create a second equation so that we can solve for the two unknowns. Now, the new thing for this question over the previous MCQ question that makes it more challenging is that the points of pivots is not very obvious. You're not told where is the pivot, and therefore we'll see how we can tackle it. Okay, so I will just take P as the pivot. I'll explain why I will choose why I can choose P as a pivot in a while later on. So if I take the point P, that means the leftmost point on the beam as the pivot, I can again just apply principle of moments on the rod. The clockwise movement is caused by the 9 Newton weights hanging 0.12 meters away from the pivot point. And the anti-clockwise movement is caused by the upward force at Q that is at the distance of 0.36 meters away from the pivot point P. So using this POM equation, I can get the upward force at Q to be 3.0 Newton, and that is half of the question solved. As per usual, the second equation we can use POM again on a different pivot point, and or I always prefer to use Newton's second law because it's easier and faster. So all the upward forces must balance all the downward forces because the whole beam is not moving. So outward forces will be the outward force at P and outward force at Q. Add them up together, that should give you a value of 9 Newton, which is the downward force acting on the beam. So that's how I can solve for the two forces. Now, bring attention to the right side of the screen, and that is the technique that I have just used. Now, when the pivot point is not obvious and not stated, as long as the whole setup is not moving at an equilibrium, you can choose any points on the beam to be the pivots. After all, a pivot is a point that doesn't rotate, and if the whole beam is at equilibrium, it doesn't move, it doesn't rotate. Most of the time it stays stationary. So we can easily just choose any of the points to be a pivot point, and that is exactly what I've done. I've chosen P as the pivot point. Now, you should try this if you are doing this for the first time. I've written it on the screen also. Try choosing Q as the pivot point, the rightmost part of the beam. Try choosing Q as the pivot point and apply POM like how I've done it. You will immediately get a P, the value of P using your POM equation, and then follow through by using second law, and you can get the two answers similar to mine, even if you start the question by choosing Q as a pivot point. So do try that and you will be able to see what I mean. So the next time when you encounter this kind of question where there's no obvious pivot point, just check if the object is at equilibrium. If it is, try and error, choose any of the points to be a pivot point. If it works, good for you. If it doesn't, choose a different pivot point and try again.